Welcome to The Explainer. Today, we're going to talk about one of the biggest challenges in AI right now. What happens when these incredibly smart models just confidently make stuff up? We're going to break down the amazing tech that acts like a fact checker, making AI way more truthful and a whole lot more useful.
So here's how we're going to break it down. First, we'll look at the problem of AI hallucinations. Then, we'll explore the powerful search tools that find relevant facts. After that, we'll see how to refine those results, and finally, how to use all of that to generate answers you can actually trust.
All right, let's dive right in with a problem that, if you've spent any time with AI chatbots, I'm willing to bet you've seen firsthand, even if you didn't have a name for it.
You know the deal, right? We ask these large language models, or LLMs, a question, and we expect a factual answer. But what do you do when it gives you something that sounds totally convincing, but is just plain wrong? Well, this has a name: hallucination. It's basically when the AI dreams up an answer. And this isn't just some minor bug, you guys. It is one of the single biggest roadblocks to using these incredible tools for really important tasks.
So how in the world do we fix this? Well, the solution isn't just about building a bigger, smarter AI brain. The real genius move is to give that brain a library and teach it how to look things up. And it all starts with a pretty revolutionary search technique. And here's the core idea. It's called semantic search. Instead of just matching keywords, it's all about understanding the intent and the context of your question. It's searching for what you mean, not just the words you typed. It's a total game changer.
And this is how it works, and it's kinda wild. This system uses something called embeddings. It turns every piece of text in its library into a set of numbers. Think of it like a coordinate. So every idea becomes a single dot in this huge multidimensional space, where concepts that are similar, like king and queen, are really close together.
And when you ask a question, yep, your question gets the exact same treatment. It's turned into a dot and plopped down in that very same conceptual map. The AI's job is now pretty simple. Just find the text dots that are closest to your question dot. Proximity literally means similarity.
This whole process of finding those nearest neighbors has a name: dense retrieval. You can think of it as the system's first, big, powerful sweep to pull a handful of potentially relevant documents out of a vast ocean of information.
But that first pass isn't always perfect. Take a look here. Someone asked about the scientific precision in the movie Interstellar, and the top result it found, just a generic description of the film. It got pulled in because it saw the keyword science, but it totally missed the real point of the question.
One way to get better at this is to be smarter about how we create that library of dots. I mean, a whole book talks about a lot of different things, right? A single dot just can't capture all of that nuance. So instead, we break the document into smaller chunks, like paragraphs, and give each individual chunk its own dot. That way, a really specific question can match with a really specific paragraph, giving us much better results.
So that first batch of results is a good start, but it's kind of like a rough draft. It needs an editor. And that's exactly where the next stage of our pipeline, re-ranking, comes in. This is where a re-ranker takes over. Honestly, just think of it as an expert librarian. It takes that initial stack of documents from dense retrieval, and carefully, one by one, it examines each of them against the original question to figure out which one is truly the most relevant. Then, it just reorders the list. And I am not exaggerating when I say the difference this single step makes can be absolutely huge. This is the kind of tech that powers the world's best search engines, turning a decent search system into a remarkably accurate one. Okay, let's see this in action. Back to our interstellar question. Look at the results now. The top document is the one that actually talks about the film's scientific accuracy and praise from astronomers. It's been given a super high relevance score and shot right to the top, while the junk is pushed down. Just like that, problem solved.
So how do we actually prove that one system is better than another? Well, we evaluate it. We run the same query through two different systems and see which one does a better job. In this diagram here, the check marks show the correct answers. System 1 is clearly the winner, right? It puts the relevant stuff right at the top. System 2, not so much.
All right, so we've successfully found the most relevant, factual information out there, but we are not done. Now comes the real magic, using that information to generate an answer you can actually trust.
And this two-step process has a name: Retrieval Augmented Generation, or RAG for short. It's simple. First, you retrieve the facts using that awesome search pipeline we just built. Second, you augment the LLM's response by feeding it those facts and telling it to generate an answer only based on the information you just provided.
This whole pipeline is the key. The LLM's answer is now grounded in those specific retrieved documents. It's no longer just pulling from its vast, sometimes unreliable memory. It's using the hand-picked relevant source material that we just gave it.
And the final output is, well, it's beautiful. You get a well-written, natural-sounding answer, but with a crucial addition: citations. Just like in a research paper, the system can show you exactly where it got its information, which makes the answer verifiable and trustworthy. This right here is how we cure hallucination.
Of course, we need to measure the quality of these RAG systems, so we look at a few key things. Is the answer faithful to the sources? Is it actually relevant to the question? And critically, do the citations it provides actually support the claims it's making? This combination of retrieval and generation is already transforming how we interact with information. But believe me, the journey is far from over.
The future is something called agentic RAG. So imagine an AI that doesn't just search one library, but can intelligently choose which tool or database it needs for the job. It might search your company's HR documents for a policy question, but then query a sales database for a customer question. It becomes an active agent, reasoning about the best way to find an answer.
And that leaves us with a fascinating question to think about. As these systems move from being simple answer finders to sophisticated research assistants, it fundamentally changes our role. We're no longer just asking questions, we're collaborating with an intelligent agent to solve complex problems. What does that future even look like?